Can you tell everybody, can you say, hi everybody?
Hi everybody.
What's your name?
Darius, D-A-R-I-U-S.
And how old are you?
3.
3, very good. Picked on number 3, my lord. Today we're gonna do a little math. Wanna do some math with Daddy?
Yeah.
Yeah?
Okay.
Okay. This is a square root function. Let me ask you a question, buddy. Where's the number 5? Right there. That's right. That is the number 5. Can you tell Daddy where the number 4 is?
Number 4.
Number 4. Hey, that's another 5, young man.
Another 5?
Yeah, is that a 4? Okay, well, let's get to work. Can you sit back a little bit?
Sure.
Okay. This is a square root function. Square root functions look typically like that.
Yeah, can I do it?
Yeah, well, we'll get to that in a second. Its domain for this guy is going to be anything greater than 5 halves. So we're going to go from 5 halves to infinity.
Infinity?
To infinity, yeah. And its range is going to be this value out here. Since that value out there, if there's nothing there, what value means nothing? You know what value means nothing?
Can you do like this?
Do you know what value means nothing?
Oh, not under that table.
Not on the
There's
table.
one here.
Yeah, we don't draw on the table. Can you say 0?
0.
0. Yeah. So this guy, it goes from 0 to infinity.
To infinity.
Yeah. Now this guy, he's a fraction, so he's got 2 things. We can't divide by a negative, and we can't divide by a 0. Or we can't take the square root of a negative, okay? So that means, for this guy, we have to make sure that we are 5 or less. So that means that we have to be less than or equal to 5.
To
We have
5?
yeah, less than or equal to 5. And this guy, x cannot be 4. I'm sorry, cannot be negative 4.
Negative 4.
Yeah. So that means we're going to go.
That is 1 and that is 1.
That is 1 and that is 1. Yeah.
Here.
So what we have here is we have a domain that goes from negative infinity to negative 4, and then from negative 4 to 5.
Can I do it like that?
We will definitely do that.
Can I do it?
We've got to finish this first, okay? Okay. And then its range, can you put your head back so everybody can see? Can you see? Because we're being filmed. You say, hi everybody.
Hi everybody.
Who's your favorite teacher?
Daddy is.
Oh, stop it. Okay, anyway, and this one...
Teachers tell women's.
I have no idea what that said. Teachers are tall women?
Teachers are called women.
Oh, teachers. So Daddy's a teacher, so he's a woman? Is that how that goes?
No, you aren't a woman. You are a man.
Oh, okay. The range for this, since it is a inverse variation function, is going to go... It's going to be an inverse variation function, so it's going to be that... oops, not x here. It's range. Y cannot be 0, because that's our...
0?
Y cannot be 0.
There's a 0 right there and right there.
Yeah?
And right there.
Yeah?
There's a lot of zeros on here.
You sure about that?
I tell you, like, a lot of zeros.
Now, are you sure that that's the right answer? You sure about that? Absolutely positive. Okay, well then we'll move on. Okay, next guy is the absolute value, or I'm sorry, the natural log of 2x minus 1. This guy just goes from 0 to infinity because he has an asymptote, vertical asymptote at 0. Let's leave that alone, son.
Daddy, what is it?
We'll get there. And it has a range of all real numbers because it's going to be everywhere. Okay? So let's move on. Let's go on to the next one. Look at that. Look at that.
What is it?
We've got a function here, and it's increasing, decreasing, increasing. And we want to know where is it increasing. It's increasing from this point, which is negative 1, 2, 3, 4, to negative 2. So we're going from, it's increasing from negative 4 all the way up here to what appears to be, I'm going to just call it, for the sake of approximation, I'm going to call that negative 3. Okay? And then it's increasing again from 0 to infinity. Now this should actually be an open parenthesis, because obviously at that point there it's just stopped. It's not a vertex, but it's not stopped, or it's not going up. Actually, no, wait, because it's not a vertex, it will be closed. My fault. So yeah, I was right the first time and then had brain fart. So they happen from time to time. And then this guy decreases from here to here. So he's decreasing from negative 3 to 0. Local maximum is going to be here at negative 4. I'm sorry, local max is going to be at negative 3, and then at 1, 2, 3, 4, it's like 4-ish. This is an ish because I don't have the actual paper I'm looking at, but you get the idea. Absolute maximum, there isn't one because it goes on forever. Local minimum is right here. That's my local minimum. That's going to be at 0, what is it, 0, 5? 1, 2, 3, 4, 5. Yeah, 0, negative 5. And it has an absolute minimum at 0, negative 5 also, because as you can tell, this guy doesn't go on forever, so this is my smallest point. Okay? Son, you gonna go sit back over there? Okay. Well, we're gonna keep moving. Oh, you eating some ice. Okay. This guy, what he wants to know is Darius picked these letters out. He said he wanted A, he wanted B, and then F. I'm sorry, C. Yes. Thank you, love. It's getting late. It's dark, and I'm certainly not in teacher mode. Sit down, son. No feet on the table. So what we're asked to do is find out, is this odd, even, or neither. So we plug in a negative. And what's going to happen is since this is an odd function, that sign's going to change. Since this is an odd function, son, people need to be able to see, that sign is going to change. But since that guy does not have an x connected to it, its sign won't change. So that means change, change, no change. This is going to be a neither. Find the function that is implicitly defined with this. We're going to have 9x squared minus 12xy plus 4y squared equals 49. And yes, I do know that's a plus. Okay? And you say plus sign.
Plus sign.
Good boy. So this gives me 3x plus 2y squared equals 49. Go through the process. You're looking at y equals minus 3 over 2x plus or minus 7 over 2 when you go through that. If you need to see it step by step, take the square root of both. You get a square root of 79 is plus or minus 7. Subtract 3x and then divide by 2. This function, if you'll give me just a moment, I need to pull this up on the laptop so that way you can see what I'm doing here, because it's a composition of functions here. Uh-oh.
I'll put it in for you.
You will? Thank you, son. Okay, so f of h of x. So the first thing we do is we write in f of x. So f of x is 2x minus 1. And then we plug in h of x, so 2h of x.
No touching, sweetheart.
Minus 1. Hey, Darius.
I'm just doing the mouse one.
I understand you are, buddy.
It's the mouse.
It is a mouse. Whose laptop is this?
Yours.
It's not yours?
No, that's yours.
Oh, that's weird. Huh.
Do
Easy.
Move that
No, don't touch Daddy's mouse, please.
So what we're going to do is then take and plug in this in for h of x, and then the only thing left to do is really to solve it. So the only thing you really can do here is to distribute, so you end up with 4 square root x plus 1 minus 1. It's really all that's going to be done with this. And it says, given the functions, find the compositions and their domains. Now, the fun thing about this one, as far as its domain goes, is the domain here is all real numbers. The domain here is going to be greater than, it's got to be x is greater than or equal to 3. So, in the end, this is going to have to be x is greater than or equal to 3. You combine them together, but you still have to keep the domain of the restriction that you have. So x is greater than or equal to 3, or we can go from 3 to infinity, whatever makes you feel more comfortable. Moving on to the next one. This one I know will make Sazzle happy, so Sazzle, this one's for you, babe. Because, you're probably asleep right now because Darius is doing some crazy stuff, and you're like, I'd just rather be messing with my phone. But it says to describe the transformation. We know that this should look like this. So the fact that it doesn't kind of concerns me. So I'm going to do like I told Gabby. Yes, Gabby, I'm talking to you because hopefully right now you're icing your ankle and you're trying to stay off it, or you're that big old, oh wait, it's in a cast. Never mind, you can't really ice that, can you? I suppose you could if you stuffed it into like a bucket of ice. It might, like create a bucket. That has the ice cubes already in it. In which case then you could just put that foot, that's casted, and just stuff it in there, and then that might actually help. But I don't know. In any event, so the first thing I need to do is I need to understand that that's a C value. So I'm going to, my next step I'm going to do is I'm going to say, pull out my common factor of 2. Okay? So now what I'm looking at is a C value that is
Back up, sweet boy.
1/2.
Instead of bag of
Because instead of putting 1/2 here, I can simply say, well, multiply the whole thing by 1/2. So I have a C value of 1/2. So that actually helps us when talking about our second horizontal asymptote.
to do like this.
Yeah, not yet. Well, I'll get you. You want to move over and sit in your chair?
Push the chair over a little bit.
Here, let's sit in your chair.
There you go. That's good.
All right. So this guy, it's negative. It's negative. Good. So the next step I'm going to do is with inside here, as I'm going to look at 1 plus e, and then I have that -1, x minus 5. So that -5 tells me that I am moving to the right 5 units. And that -1, obviously that's my b, so my b is equal to -1, so that doesn't affect anything as far as a horizontal stretch or shrink. And then I have a value out here of 0, so that means I have a horizontal asymptote at 0. I have another horizontal asymptote at 1/2.